Ever wondered how a simple triangle holds the key to understanding complex wave patterns? Today, we're diving into the world of trigonometry, specifically how to find all 6 core trigonometric values from just 2 sides of a right triangle. By the end of this journey, you'll not only understand how to calculate these values, but also see their elegant relationships. Let's start with a right triangle. We're given 2 sides, the opposite side measuring 5 units, and the adjacent side measuring 12 units. To find the third side, the hypotenuse, we use the powerful Pythagorean theorem, a squared plus b squared equals c squared. Plugging in our values, 5 squared plus 12 squared equals c squared. This simplifies to 25 plus 144 equals c squared, which gives us 169 equals c squared. Taking the square root of both sides, we discover our hypotenuse is 13 units. Now that we have all 3 sides, we can define our primary trigonometric functions relative to an angle, let's call it theta. Sine of theta is the ratio of the opposite side to the hypotenuse, so sine theta equals 5 over 13. Cosine of theta is the ratio of the adjacent side to the hypotenuse, thus cosine theta equals 12 over 13. And tangent of theta is the ratio of the opposite side to the adjacent side. This means tangent theta equals 5 over 12. But trigonometry isn't just about these 3. There are 3 reciprocal functions. Cosecant theta is the reciprocal of sine, so it's the hypotenuse over the opposite side, which is 13 over 5. Secant theta is the reciprocal of cosine, meaning the hypotenuse over the adjacent side, giving us 13 over 12. And cotangent theta is the reciprocal of tangent, or the adjacent side over the opposite side, resulting in 12 over 5. So, from just 2 sides, we've successfully calculated all 6 trigonometric functions. These values are the fundamental building blocks for understanding waves, oscillations, and even the motion of objects.